Hi, boys and girls. All right, we're going to graph the walk that I took that was fast, then slow, starting from the zero card, the 0 meter card, heading out to the 8 meter card over by the sliding door. But this one's fast and slow and it makes a different shape, and I'm excited to show you this. All right, so we have our data here, and all we have to do is turn our data into coordinates. So the first point is already there for us. We started at the 0 meter card, so 0 time and 0 distance. And then it only took half a second to get to the 1 meter card, and then another half a second. So then it was 1.5, another half a second here. And then it took a whole second to get to the 4 meter card. So that should be 2.5 right there. All right, and then to get to the 5 meter card, it was all the way up to 4 seconds, second and a half. And then to get to the 6 meter card, it was 7 seconds. And then to get to the 7 meter card, it was 10 seconds. And then to get to the 8 meter card, it took 15 seconds. All right, so let's see how that graph turns out. I wonder if you can predict how it's going to look. All right. I know in the last one that we did that since it was fast, or so slow then fast, the end of the graph turned into a steep diagonal. And I feel like now that we're doing fast then slow, it will probably start off steep and then end up flat. And let's see how that works. All right. So either way, our first point is 0, 0. 0 distance and 0 time. Then it's only 1/2 of a second to go 1 meter. And then only 1/2 of a second over to 1 to go 2 meters. So it is starting off steep. See this? See that very steep slope? All right. And then it only took a half of a second to go 3 meters. So 1.5. So here we are. Right? And then we have 2.5 seconds to go 4 meters. So 2.5 up to 4. All right. And then 7 seconds to go 6 meters. Ooh, we really slow down. 7 seconds to go, wait a minute, no, to go 4 seconds. Sorry, 4 seconds to go 5 meters. There we go. And now 7 seconds to go 6 meters. 7 seconds, 6 meters. All right. And then it took 10 seconds to go 7 meters. Crawl over to the 10 and climb to the 7. All right. And then 15 seconds, all the way out to 15, just to go 1 more meter. Because remember, I was walking ridiculously slow. So do you see how it's made still a curve, but a different looking kind of curve? Where it's starting off very steep right here and then getting flatter toward the end. All right, so remember on this graph, we're going fast. Right here is a fast speed, and it's fast because the diagonal is steep. See right here? And then all you have to do to tell whether you're increasing or decreasing speed is just to circle about the last third and decide if it's flatter or steeper. We already looked at the front part. That's pretty steep, right? And I know that a steep diagonal is fast. A flat diagonal or a flatter diagonal is slow. And I know that a horizontal means stop. So that stopping horizontal is always going to help you remember that if you have just a little bit of a slope, it's a slow speed. but a very steep slope is a fast speed. So because the line, the curvy line that this graph made from my walk of going fast then slow, because it ends flat, I know I'm ending slow, so I know that my speed is decreasing. Decreasing speed. Decreasing speed. Remember, the trick to anytime you have to identify whether your speed is increasing or decreasing is to simply circle the back, circle the last third, and then decide if you have a steeper or a flatter slope at the end. And if it's flatter at the end, you know you're slowing down. And if it's steeper at the end, then you know the graph is speeding up. All right, we'll stop there for now. I just love the acceleration graphs and how they get all curvy. All right. But y'all know science is my thing, so. Okay, and I am going to say goodbye now. Love you.